We're going to create trapezoids using these 4 side lengths. We can choose 2 of them to be our bases, and then the other 2 side lengths will be the other 2 sides. These are all the ways that we can choose 2 of our side lengths to be the bases of our trapezoid, but you might suspect that these won't all produce valid trapezoids with a positive area. So we need to check to make sure that these are valid side lengths for the bases. We can do that by sketching a trapezoid with the first pair of bases being 3 and 5. And then we can connect one vertex to the opposite side this way so that these 2 side lengths are parallel. If 3 and 5 are the lengths of our 2 bases, then the other 2 sides have lengths 7 and 11. And then we can check that triangle inequality is satisfied for this triangle that we've created outside of this parallelogram. We do that by comparing the sum of the lengths of the 2 shorter sides to the length of the larger side. The shortest distance between 2 points is a line, so we want 11 to be less than 7 plus 2, which it is not. So this is not a valid triangle. It's also not a valid trapezoid, so we can skip that. Let's try the second pair of bases. The bases have lengths 3 and 7, so the other side lengths are 5 and 11. Again, we see that the sum of the lengths of our 2 shorter sides is not longer than our third longest side. So triangle inequality fails, and this will not generate a valid trapezoid. Let's try our third pair of base lengths, 3 and 11, not drawn to scale. That leaves our other 2 side lengths are 5 and 7. Here we have triangle inequality is satisfied. 5 plus 7, our 2 shorter sides, is greater than 8. So we have our first valid trapezoid, and let's go ahead and find the area. We do this in the usual way, finding the heights, assigning some variables, and then using the Pythagorean theorem on our 2 right triangles and setting them both equal to the square of the height. We solve for x and then plug this in to solve for h. The height of this trapezoid is 5 root 3 over 2. The average of the bases is 7. The area of this trapezoid is 35 root 3 over 2. Let's check to see if these other 2 base lengths, 5 and 7, result in a valid trapezoid. We draw our parallelogram as before. This means the 2 legs of our trapezoid have lengths 3 and 11. And again, we see that this fails triangle inequality. This won't result in a valid trapezoid, so we don't have to calculate its area. Let's go on to the 5th pair. Bases are 5 and 11. The length of this side of the triangle is 6, which leaves 3 and 7 for the 2 legs. And here we have that the sum of the 2 shorter sides, 3 and 6, is greater than 7. So triangle inequality is satisfied. This is a valid trapezoid. Let's find the height. Again, using Pythagorean theorem. Solving for x, we're a little concerned because x is a distance and we get negative 1/3. But I think we can explain this with a trapezoid that looks something like this, where this vertex at the bottom here is to the right of the vertex at the top. So let's solve for h. This gives us a height of 4 root 5 over 3, and the average of our bases is 8. So the area of this trapezoid is 32 root 5 over 3. Let's try the next pair. This one has bases of length 7 and 11, which means this triangle has side length 4. The 2 legs have side lengths 3 and 5. Looking at this triangle ABC, it has side lengths 3, 4, and 5, which actually makes this a right angle. So this is really what our trapezoid looks like. Our height is easier, it's 3, and the average of our bases is 9, so the area is 27. The problem asks for the sum of all possible areas, written in this format. That's 35 halves times the square root of 3, 32 thirds times the square root of 5, and 27. And the answer is supposed to be the sum of the values of all of these variables. So let's add these and convert our fractions into mixed numbers. And keep adding. The sum of these 2 fractions is between 1 and 2. So 63 is the greatest integer that's less than the sum, and that's our answer.